Hello everyone, welcome to Cloud EML YouTube channel. My name is Sonali Thakur. So today we are going to create a kind of a machine learning model which can predict whether the loan of the applicant should be approved or not. So we already know that loans are the major requirement of the modern world, and this is one of the way through which banks gets a major part of the profit, and through loans the people gets profit in buying the luxurious things like cars, lands, or houses. So now the question arises, in what basis banks provide loans to the applicants? So whenever any applicant applying for a loan to the bank used to read the data or the information of the applicants related to applicants' gender, marital status, income. So based on that data, banks used to decide so whether they are going to approve their loan or not. But so previously, this things was done by the loan officers in the bank. But with the rise of machine learning, now banks are using the machine learning technique to do this task. So we will create such kind of machine learning model right now, which can able to predict whether the loan of the applicant should be approved or not. So for that, for that, let's start with understanding the life cycle of machine learning project. So building such kind of machine learning model, we need a kind of a data set which has the information about the loan applicants, and whether the loan of the applicant has been, approved or not by the bank. So there is a platform, Kaggle, where you will see a lot of tons of data set. It is a very useful site for the data scientist or a machine learning engineer for practicing and building such kind of models. So just go through this link. If you search this link in Google, or you or just go through this link. So this is the link. Go to the first one. Download the data set from here. Then just download the data set from here. So this is the data set. So the data set contains the columns like, unique ID, gender, marital status, yeah, loan ID, gender, marital status, dependent, self-employed, applicant income, co-applicant income. So this is a data set in a CSV format. Just download the data set from here. We are going to use this data set for our building machine learning model. Okay, so the life cycle of ML project starts with data collection. So just go through that link and download it from there. So this data set contains information about loan applications, including various attributes related to applicants and whether their loan applications were approved or not. So let's start understanding the features that is present in the data set. So the data set contains total 13 features. Let's discuss how each feature in the dataset could potentially impact the target feature, which is loan status. So loan status is our target feature, which indicates a loan status has two values, yes or no. So yes indicate that the loan has been approved by the bank, and no indicate that the loan has not been approved by the bank. So whatever the model that we are going to, build out, that model used to predict on this loan status. So whether the loan of the applicant should be approved or not. So this is our target feature. Apart from the target feature, we have another feature like loan ID. Loan ID is a kind of a identifier or a unique ID. So whenever any applicant apply for a loan in a bank, the bank used to provide him or her the ID number for keeping the record. So it does not contribute to decision making because it is just kind of a ID. It helps the banks to keep the record. So let's check the another columns. Okay, so the another column is gender. Gender gives us the information about the gender of the applicant, whether it is male or female. So sometimes what happen, some banks used to, set any gender-based discrimination for approving the loan applicant. So at that point of time, gender plays a very important role. So if there's evidence of gender discrimination, it could affect loan approval. That is our target variable. After that, there is another feature that is married. So married has two values, that is yes or no. So bank used to check so whether the applicant is married or not. So if the individual is married, then then the bank may think that okay, so married individuals may perceive more financially stability. They have a good source of income, so it will give a good impact on the loan approval target feature. So lenders might be more inclined to approve loans for married applicants because they might think that they have a financially stability. So based on that, they can approve their loans because they might think that they have the chances of repayment back, so it would affect the loan status target variable. So the next feature is the dependence. Dependence indicate the number of, dependents or the number of people lived with the applicant. So basically it indicate the family size. So if the family size is too high, it means that the financially responsibility of the applicants is much higher. So lenders at that point of time think the applicant's ability to repay the loan considering their family size. If the family size is too big, then lenders may think that the financially responsibility is much more on the applicant. So yeah, based on that, bank could decide. So dependence also plays an important role. Next one is education. Education has two values, yes or no. Education has two values, graduated or not graduated. So if the person is graduated, so if the person is graduated, then it means that they're having better job opportunities, and they might have better job also. So based on that, also the bank can decide so whether they are going to provide the loan or not. So the level of education might be a proxy for the applicant's earning potential and financial stability. Next one is the self-employed. Self-employed indicates basically the source of the income, or the source of income, or the source of, the work where the person is working. So lenders might think the stability of self-employed applicants' income sources. So based on that, they can also decide. So these are all the informations that applicants used to provide to the bank, and the bank decides by reading this data. Next is applicant income. Applicant income means the amount of income that the applicant is earning per month. So sometimes what happened, bank used to set some threshold income value, like for example, just think like that. So one bank has set the threshold income is 25,000. So if the person's monthly income is less than 25,000, then they will not provide a loan more than 3 lakh or 4 lakh. So this may be some, cases in some banks. So that's why the applicant income plays a very important role at that time. So higher income generally indicate a better ability to repay a loan. So however, extremely low or high income might be a red flags. Lenders may set income threshold for loan approval. So when will it be a red flag? When the lenders or the banks set the threshold for loan approval. So at that point of time. Next is co-applicant income. Co-applicant income means if the applicant has another member in their family or another person uh, uh, which is also have a good source of income. So the income of the co-applicant can supplement the household income because it increases the chances of repayment of loan to the bank because the applicant has a good financial stability if he or she has a co-applicant income. So a higher co-applicant income may positively influence loan approval. But this is not possible for all the applicants in all the cases because there may be some applicants which do not have co-applicant income also. But if the applicant has, then it will add a positive impact on the loan approval target feature. Next is loan amount. Loan amount, basically the amount of the loan that is the applicant is applying for. So lenders will assess whether the requested loan amount align with the applicant's income and financial situation. So the bank or the lenders will check the loan amount that the applicant is applying for. So whether it is aligning with the applicant income or the information that the applicant is, filling. So based on that, they can decide. Next is loan amount term. So loan amount term is the time the term of the loan affect the shorter terms or the higher terms or the number of months you can say in which the repayment of the loan will be done by the applicant. So if the shorter terms, then you can think that the repayment of the loan is very fast. But if the loan amount term is longer, then we can think that the interest that the applicant is going to pay will be much higher because if the loan amount term will increase, the repayment time will increase or the term will increase, then the overall interest will also increase. So yeah, this is the loan amount term. Next is credit history. Credit history basically the good credit history is one of the most important feature because it indicates the most uh, chances of repayment of the loan back to the bank. If the person's credit history is one, then then the bank can think that okay, the score is too good to approve the loan because if the credit history score is good, then they have the chances of getting their repayment back. So if the credit history is too bad, then there is a chances of not approval of loan approval. So it always plays a very important role when we are dealing with such kind of model building. Next is property area. So sometimes what happen for applying the loan at the time of applying the loan, applicant has to give some properties papers to the bank. So the bank can decide based on the property area that whether the area belongs to a rural or urban. So based on that also they can decide their decision. So yeah, these are all the features. I hope you guys understood all the features and what the data set is telling about the applicants. So the first step of the machine learning project is gathering the data sets. You can download the data set from the Kaggle. I have explained you all the features. I hope you guys understood. So let's move to the second cycle, that is data cleaning. So after understanding the data set, we have to do the data cleaning. In data cleaning, we do filling the missing values. So maybe there might be some missing values present out there. So we will fill those values. Might be there outliers present. So I will explain you in more detail about missing values, outliers, accuracy, standardization or normalization when we will do the practical implementation. So right now, just understand that what the steps that we are dealing in data cleaning part. So in data cleaning, we will impute missing values, deal with outliers, standardize our data features. And after doing the data cleaning, we will do data analysis. In data analysis, we will visualize the features. Whatever the features that here are gender, married, education, dependence, we will visualize all these features in graph format, okay, in a categorical plot or just plot, or we will check the correlation between each features. So visualization tools can be helpful in this space. We will use visualization tools like matplotlib, seaborn, okay. And after doing the data analysis, we will do the feature engineering. In feature engineering, we will check out some features like there you can see that there are features uh, applicant income, co-applicant income. So there are two income source of the applicant. So we can calculate the total income of the applicant. So this kind of changes we can do in feature engineering part. Creating new features or modifying the existing ones to improve the model's performance. We will also do encoding technique. And in encoding, we will convert the categorical data type to numerical one. For example, let's see that in in property area, we have two values like rural or urban. So we will convert this rural or urban categorical data type to a numerical one. So either one or zero. So I will explain in more detail when we will do the practical implementation. So after doing the feature engineering, we will move to data splitting. In data splitting, we will split the data set into training and testing data set. Training data set is used by the model to train the data set or train the model and its testing data set is used to check the performance of a trained model. So the training set is used to train the model, and the testing set is used to evaluate its performance. After splitting the data set, we will choose the models. So since it is a since see in a target variable we have two values. In a target variable loan status we have two values, yes or no. So whenever there is a categorical data type, or there is a two values categorical data type in a target variable, it means that it is a binary classification problem statement. So for solving a binary classification problem statement, we use models like logistic regression. It is a basic and simple machine learning model to solve with this kind of problem statement. And after that, we can go through decision trees and then random forest and then support vector machines, or there is also a decision tree, k nearest neighbor. So these are all some supervised machine learning models that we can use for solving the binary classification problem statement. So I hope you guys have the understanding of this machine learning models. If you want to in more detail about this machine learning models, then write in the comment. Next, after training the model, so after selecting the model, we will train the selected model using the training data set. So in data splitting part, we have splitted a data set into training and testing, and we will use that training data set to train this models. So we will train all these models, and after that we will check the accuracy. Accuracy means how much the percentage of that how much percentage the model has correctly predicted the output. So accuracy tells us those value. Precision recall is also one of the technique to see one of the metric score to see the performance of the classification problems. Was all the overall, this was all the overall understanding of the data set and the life cycle of machine learning problem that we are going to perform, the steps that we are going to perform to build a kind of model, ML model. So let's start with the practical implementation. So for doing the practical implementation, we have to install some necessary libraries uh, for doing data analysis, data cleaning, and data visualization. So let's start with importing the libraries. So first of all, we will import pandas. So import pandas as PD. Pandas is a library for doing the data analysis, data manipulation part. Next, import NumPy as NP. NumPy is a numerical Python package which help us in calculating the mathematical things. Next, import Cbon as SNS. We will import Cbon and Matplotlib for doing the uh, data visualization things. Next, after Matplotlib, we will import warnings. So warnings help us to ignore all those unnecessary messages that arise whenever we do the visualizations. So it will help us to ignore all those messages. So let's run. So first of all, we have to add one more line, matplotlib line. Okay, so now let's run the cell. So yeah, all the necessary libraries have been installed. So let's start with importing the dataset. For reading the dataset, we will create one variable df. So here we will read the dataset. For reading the dataset, we have to write pd.readcsv. It is a kind of a function through which we can read the dataset. I've already downloaded a dataset from that link. I have shared the link on my document file. So just go through that link and download it from there. It is openly available in Kaggle platform. So go through that link and download it. I will upload it from my drive file. So this is the dataset. Copy the path from here and paste it here. So let's run df. Let's see what So yeah, this is our data set. The data set contain the unique identifier loan ID, gender, married, dependents. So your gender is an object categorical because it has two values like male and female, and it is like object or categorical data type. Married has two values, no or yes. So it is object data type. Dependence has numerical values. Yeah, but there is also one more value like 3 plus. So maybe it is a kind of a object data type. We can check all those data types by using the function df.info. There is one function in in pandas. So yeah, let's see now the first of all the features. So dependent is one of the feature: education, self-employed, applicant income, co-applicant income, loan amount, loan amount term, credit history, property area, loan status. So in loan status, there is two values, yes or no. So yes indicate the applicants whose loan application is accepted by the bank, and no means the applicant whose loan application is rejected by the bank. So yeah, this is the credit history. One means the score is too good to approve it, and zero means the credit score is too bad for approving the loan application. So that's why here the loan has been rejected. So in co-applicant, we can see lots of zero values is present. And in a loan amount term, we can see there is a non value. So this non value may be present many features because all the rows has not been shown up here. See, till 4, and after that there are many rows in between them. After that it starts with 609. So we can see the first top 5 rows by using the function df.head. It helps us in uh, giving the first top 5 rows, and there is another one function df.tail. It returns the last top 5 rows. Yeah. So this is the last top 5 rows, 613. Total 614 rows is there because the number of rows starts from 0. We can check the dimension of the data set by using the function df.shape. It is a kind of a function already present in Pandas library. From that we can use that. So from df.shape we can see the dimension 614 rows and 13 columns. So there is also one function df.columns which results in returning the names of the features. So all the features present here: loan ID, gender, married, dependents, education, self-employed. So df.columns returns all the names of the features. So let's see. So whenever we do data analysis things, so first of all we used to check the names of the features, so whether there is any error or present or not. But the names has been corrected only. There is no some error, so we don't need to require do some things out there. So after that we have to check the info of the data set, like what is the data type of the features present. So df.info is the function from which we can check the data type, non-null count, column names. So all of this, from this we can see that loan ID, gender, married, dependents, education, self-employed, all of this are object data type. And from applicant income to credit history, all of this are numerical data type. And again, property area and loan status is a categorical data type. So df.info gives us the information about the features. And after that, we can check the total number of missing values present in each feature by using the function df.isNull.sum function. It returns the total number of missing values in each feature. So gender has total 13 missing values, married has 3, dependent has 15, self-employed has 32, loan amount has 22, loan amount term has 14, credit history has 50. So it returns total number of missing values present in each feature. So we have to fill all those null values because if we will not fill those, then it will return some error, or the model that we are going to build will not be an accurate one. So for that, there is a technique of filling out all those null values. For filling the object data type, we always use mode because if in object data type we of course it is not a numerical one, so we don't use the calculations for those. And mode is a kind of a mode is a kind of a central tendency that gives out the most number of occurred items. So if in a gender feature male occurrence is more, then it will then the mode of the gender feature will be male. If in a married feature the persons who have married has appeared more number of times, then the mode of the married will be yes only. So let's start with filling the missing values. But when we fill the null values of numerical data type, we have to check whether there is outliers present or in a numerical data type or not. So if there is any outliers present, then we can use the median value to fill the null values. And if there is no outlier, then we can go through the mean value for filling the null values. So first of all, let's check the outliers. Checking the outliers. Fixed size 12, 12,8. As soon as that box plot, SNS dot box plot data equal to. So, okay, so we have imported df. So we have named our data set df. So we will use. So whenever we import, whenever we, you know, visualize the box plot, we have to mention the data name. So data is a variable where we set our data frame value, like we have read our data set in a df variable. So we will use that here, df fixed size equal to. So yes, we can see that. So this the dots you are seeing in black color. It is an outlier. Outliers are those values that is actually different from the remaining values present in a feature. Let's say since the values that is more in applicant income is more outliers, so we can see the applicant income like there. We can see that this is the 2,900, 4,100. Here it is 8,000 something. This is 4,000. This is 2,000. 7,000, 4,000. So we can see that the values are very much, the values are have a very lot of difference. Since it is a 2,000, but here it is a 8,000. So the values are really very much different. So whenever this type of values occur like 8,000, 7,000, then it will be a kind of a outlier. So that's why in applicant income, the outliers are more. Same in co-applicant income also. In co-applicant income, we can see that mostly the values are zero only, but here we can see that the values are 240. So it is an outlier. In loan amount term also, we can see that the values are 71, 40, 187, 133. You know, so here we can see that 40 is too less, so 40 may be the outlier. 253 is the too large, so it may be an outlier. So the values which are not relevant with the remaining values that may be considered as an outlier. So yeah, so for filling the null values of numerical data type in applicant income or co-applicant income, we will use median because the outliers are more present here. Why we are using median values? Because median is less sensitive to outliers, but mean is more sensitive to outliers. So that's why we are using here. So let's fill the values. PF loan amount. So for filling the null values, there is a function dot fillna function. So dot fillna means filling the null values. So which value we are filling? We are filling the median value. So we will calculate median value inside the fillna function. Dot median. We can check this median value in a separate column. Sorry, in a separate cell, not a column. Separate cell. Let's run the cell. Okay, so we can see the value is 128. So if we check the mean value, like if we calculate the mean value of loan amount term, let's see what will be the mean value. Understand? So yeah, the difference is like median is giving 128 and the mean is 146, little bit large. So yeah, we will fill the median value here. Let's copy the code and fill all those values for the other features. So let's see which numerical feature has null values. Loan amount has loan amount term, credit history. Loan amount done. Co-applicant income. No, there is no co-applicant income. So loan amount done. Next loan amount term. So loan amount term has not any outlier. So we can go through with mean value. So loan amount has done. Next credit history. Copy the code. Paste the name here. So credit history has also not outlier. So we can use mean value here. Cut this because only three numerical feature is there which has missing values. Run the cell. Okay, so here I have written two times. Now done. Run the cell. Yeah, so the null values of numerical data type has been filled out. Let's fill the null values of object data type. Fill the null values of object data type. Copy the code from here and make changes in this code only. So the object data type are gender, married, dependents, self-employed. And yeah, gender, married, em- dependents, self-employed. Make changes here. Change the name to gender, gender, gender. And we will use mode because it is a object data type. So let's check this mode value in a separate cell, df gender dot mode. Let's see what value it is returning in a separate cell. Run the cell. So it is returning male, but we only need this value, like we only need male to fill this value because dot fill now function will accept only one value, but here it is returning like this. So we will do the indexing here. So yeah, so when we mention the indexing 0, then it is returning a single value that is self. So we have to write the indexing here. Okay, so gender has been done. Next, after gender, the other feature is married. So let's make changes in the second feature, married. Copy the married one and paste it here. Change it and give the indexing. So after married, the other one is dependents. give the mode value, to give the indexing. Let's run the cell. Okay, so we have filled, remove this one. Okay, so we have filled the null values of numerical data type and object data type. So previously when we checked the dot from the dot is null dot sum function, we see that the null values has been appearing. But after filling the null values, let's again check that whether it is filled or not. So if it is filled out, it will return only 000. See? Okay, so there is one feature left, that is self-employed. So self-employed is also a object data type. We have to fill those values also. Copy it, right here. The other one is self-employed. So we missed this feature, self-employed. Run the cell. So the self-employed also done. Now let's try rerun the cell. Let's check. Okay, so now we can see that all the null values has been filled out. So now it's all returning 000. It means that no null values is present in any of the feature. So after, filling all those null values, let's see some visualizations of the features. So first of all, let's see the visualization of gender feature. Like we can see that, the difference between the male and the female, that by seeing the visualization we got an idea that what is the difference between the number of male or female, you know who has applied for loan approval. So print number of people who took loan by gender, number of people who took loan by gender. So there is one function, uh, count dot values, so which help us in returning those gender dot value counts. So it is a function, if a gender has 5 male and 7 female, so dot value counts function will count all those object data type and return the number of, that how much total male is present and how much total female is present. So dot value counts to that task. And after calculating it, plot it also. So count plot is a function in SNS library. So let's in x-axis plot gender, and in y-axis, so in y-axis it will appear the count, so we don't need to give that. So data equal to df, we have to mention the data, and palette equal to, so you can see that palette is a, it is a variable present in count plot. We can give it to set1 or set2, any. So you can see that there is a palette. There are many things out there, that is hue, colors, saturation, right? So you can explore all of these things. So I am giving setting to set1. So let's run the cell and see the count plot of, yeah. So from here we can see that male which is applying is total 502, and female which is applying is total of 112. So there is a lot of big difference between male and female who is applying. So yeah, this is the visualization that we are seeing. Number of people who took loan by gender. So let's check the number of people who took loan by marital status. Copy the code from there and paste it here. So here we will check based on marriage feature. Run the cell. Yeah. So we can see that the couple, that the person who has married, have applied loans more, and the single one has less who applied for loan. So yeah, this is based upon married. We can also visualize for other features like there are, you know, dependence, education. Based on education also we can check. Let's check based on education. Make changes only in feature name. Run the cell. So there is some error. Yeah, cut it and run again. So yeah, we can see that the person who has graduated has applied more than the person who has not graduated. So the person who has completed, see, the graduated people is 480 who has applied for loan, and not graduated 134 who applied for loan. So yeah, we have seen the visualization. We can also see the correlation, correlation of the features. So let's see the correlation of the features. So for calculating the correlation, there is a function, df dot corr. So it will calculate the correlation and we can plot it, fixed fit of figure size. So you can make changes in figure size, like if you need a bigger figure, then you can give a bigger number, otherwise set for a smaller one. So there is a heat map in SNS library, which which visualize the correlation. So if we put the value of correlation, like if you see, if we count the, like you can see in a separate column, what is the correlation value? Copy the code, run the cell. Yeah, so here you can see that the applicant income is, of course, it will be one because both are the same column only. Applicant income and co-applicant income relationships is in negative term. Applicant income, loan applicant income correlation is 0.5. Next, applicant income, loan applicant income correlation is again in negative. So applicant income credit history is also in negative term. So so it shows the relationships. Co-applicant income, applicant income in negative. So yeah, so applicant income is more correlated with loan amount. Co-applicant income is more related with here 0.189. Loan amount is more related with co-applicant income. Sorry, applicant income. Loan amount term is more related with loan amount. Credit history is more related with loan amount term. So there are some negative correlation also and some positive correlation also. Correlation means the relation between two features, like it is indirectly dependent or directly dependent. Okay, so one is increasing, that the other may be decreasing in a negative relation. If it is a positive relation, so if one is increasing, then the other, then what is the rate of change of effect on the second feature? So SNS dot heat map will visualize this in a graphical manner. So there are some, so there are some variables that we have to set. So there are one like n not is set to true, cmap blue. So the color will be blue or purple, something like that. It will appear. Run the cell. Yeah. So you can see this is the graph. So based on the correlation value, like since applicant income is more correlated with loan amount, so applicant income is more related with loan amount. So you can see applicant income is more related with loan amount, so 0.7. And since it is showing 1 because applicant income is, of course, highly more related with the same feature only, so that's why it is showing like 1. So based on the correlation value, the color of the relation appears. So you can see the scale only. If it is more related, then the color will be like this. If it is related, if the value in between 0.8, 0.6, then the color will be this in this color. If the value is in between 0.6 to 0.4, then the shades color will be like this. So this is the scale. So through which we can visualize the correlation. Next, so yeah, these are all the data analysis part that we did till now. Data cleaning, filling the null values, visualizations. So all the data cleaning and data analysis parts we did till now. So next we have to move to feature engineering. So in feature engineering, we will check the features of the data set and let's see what the new features or what's the changes in the features that we can do. So for the one thing is that we have to do the label encoding or one-hot encoding for converting these categorical data types to a numerical one. So that is much important. And before that, we can see that there are two income features. One is applicant income and other is co-applicant income. And we can see that in co-applicant income, many values are in 0, 0. So it is not so much important. So what we can do, we can drop these features because it will not add more, impact. But what we can do, we can create one more feature, total income. So in total income, we can add applicant income and co-applicant income, which will return the total income of the applicant. And after that, we can drop this co-applicant income. So let's do that. Because if we do not create a total applicant and just drop the co-applicant income, then then the values that is present here will not be helpful. So before dropping it, let's calculate the total applicant income. Start with total applicant, total applicant income. So since we are creating a new feature, so we will name a new feature here. So we are giving a name as total applicant, and total applicant equal to df. What is the name of the feature? Applicant income. So let's write applicant income plus df co applicant income. So it will create a new feature of df total income. Sorry, total income. Yeah, why I've written total applicant. It will be total income of the applicant. So let's check the features of the data set from df.head and check whether the new feature has been created or not. So this is applicant income. This is co-applicant income. Let's see. Okay, so you can see now total income has been created. So which returns the sum of these two. Like applicant income is 5849. Co-applicant is 00 in the first row, so it is returning 5849. Sum of 45831508 is 6091. So this is the total income that has been created. So now let's move to check the values of the numerical features. Like in applicant income, we can see the values are like in this way. So we can see that there are many, changes in the values like 5849, then 4583, then 3000, then 2583. So we can see that the values are very much skewed. Like there are many changes in the values. So we can apply a logarithmic function in this features so that the values which has been we can make this features should follow a normal distribution since the values are very much different. So we can say that the values that the features has been following a skewed distribution. So we can convert those features to convert it into a logarithmic or normalization, uh, normalizing it. So we can do this. So let's apply log transformation. So why we are doing it? Because it will help, to do the next process in machine learning task. And it will also help us the model to do the calculations easily in backend. Let's apply log transformation. So let's apply log transformation df. The first will be like applicant income. So we are applying log transformation. So after log transformation, application, if we apply it, then there will be some changes in the feature. So let's name the new feature as applicant income log after transformation. Okay. So let's do this. Then df. So not df. Since we are applying long transformation, so there is np.log in a numpy library. We will use that one to apply log applicant income. So this is a formula, and we are adding one value. So yeah, from this we will apply the log of transformation, and after applying the log transformation, we can see the distribution also from the disk plot. So this plot will return the distribution of the features, the new feature that we have created, income, applicant income log. Let's run the cell. So yeah, you can see that now the distribution of the feature follows a normal distribution. And the new features has been created like df applicant income log. So if you rerun this cell, if you rerun this cell df dot head, then you will see that the new feature has been created, which is applicant income log. So this is applicant income. The values is 5849, and this is applicant income log. So now you can see the values is converted into 8.674. It means that we have normalized these values. We are fixing these values in a range of, yes, you can see that the values are in the range of 0 from like somewhere in between 3 or 4 to till 12. So the values lies between in this values, in this range. So basically we are scaling the values. So since we have created a new feature applicant income log, then after that we can drop out this feature applicant income. Same we will do for co-applicant. Co-applicant income, we don't require it because we have just created new feature total income. So we will drop this values. We will make the transformation on this feature and we will drop this feature also. Same we will do for loan amount term also. Yeah, so the process will same only. Let's copy the code and do the transformation for other features. Applicant income is done. Next is co-applicant income. Uh, co-applicant income is not required also because basically we will drop that only because most of the numbers in the co-applicant income is zero only. So next is loan amount. So loan amount log. Make changes in loan amount. Run the code. So there is some error in the spelling. loan amount log, and there it is, loan amount log. So what is the issue here? Let's check what is the issue. A loan amount. Why it is, yeah, so there is issue. Let's rerun the cell. So now you can see that these values have also been normalized. So let's do for the other cell. So the other column is loan amount term. So let's create loan amount term log feature, loan amount term log. Make changes here also. Loan amount term. Same here. So basically, we are converting all these big values to a small range, and this process is also known as normalization. And we can do this by applying the logarithmic transformation. So yeah, it's also gets converted. So after this feature, the other features will be total income, the new feature that we have created. So we can make changes on those feature also, on that feature also. So the name of that feature is total income. Total income log. Total income. This one is total income log. Run the cell. So there is some, okay, A will not be there. So let's run the cell. So now we can see that it is also gets normalized. So okay, so all the features that is required for converting it into, logarithmic function or making transformation to those, we did now. Now just check from df.head to all the new features that have we are now created. So this is the old one, applicant, applicant income, co-applicant income. This one is the old features that we will drop now because it is not needful for us because we have made the transformation and we have converted this into those values like applicant income. So now you can see the values are getting so much smaller now. So now the calculations will be much more easy and the generalization will become much more easy. So now we can drop out those unnecessary features that we have got transformed into this loan amount term log, total income log. So yeah, this one. I think there is some changes. So there are some change. We have to rename this feature because A total income. Okay, by mistake, I have written here A. So no worry. Let's move to other thing like dropping the features that is required. So drop unnecessary columns. So columns equal to columns equal to which columns we are going to drop applicant income, co-applicant income. Co-applicant income has mostly 0 0 values. So that's why we are dropping now because we have created a new feature that is total income in which we have used these values. So we can drop it now. Next one is loan amount term. So we can drop this features. So let's write applicant income. Next, co-applicant income, loan amount. So we are creating a variable calls in which we are writing the columns name which we are going to drop out. Next is loan amount term. Next is total income. Since we have converted the total income to total income log, so that's why we can drop out that also. So there are one more feature, that is loan ID. Loan ID is also not useful for building models, so we can drop that too also. So yeah, so there is one, feature, sorry, feature not, there is one function, df.drop. So through that function, we can drop the column. So df.drop will remove all those columns from the data set. So let's mention the columns names that we are going to drop. So which columns that we are going to drop? So this columns that we have created a new list. So mention the list name here, and x is equal to 1 means column. If x is equal to 0, then it means rows. If x is equal to 1, then it means column. So after dropping it, just check the df.heads that whether the columns has been removed or not. So now you can see the columns that applicant income, co-applicant income, loan amount term, all has been removed now. So the new features that we have generated are present here. So yeah, we did that. Now the other thing in feature engineering we have to do, that we have to convert all this, categorical data to numerical data. So the other task is do encoding. So there are two types of encoding technique. The one is one hot encoding. So encoding technique is, so there are two types of technique. One is label encoding, and other one is one hot encoding. So let's understand in which time we have to do this. So whenever we have some conditions like this, that we have gender, male or female value, married, no or yes value, education, graduate or not graduate. So if there are this kind of values like two or three, then in that case we use label encoding. In label encoding, what it does, it will replace male to like 0 or 1, or female in place of female, it will give 1. So it will replace 0 or 1 in place of male or female, in place of yes or no, in place of graduate or not graduate. So it is a simple technique of do. But when we have lots of categorical variable, like there may be a state feature. Let's, for example, there may be a state feature, and here we have names like Assam, Bihar, Maharashtra, Uttar Pradesh. Then in that case, we have to do one hot encoding, because all the states have some importance. We can compare. Okay, so in that case, we can do one hot encoding. But in case of this, like yes or no, graduate or not graduate, male or female, so then in that case, we can do label encoding. So for doing the encoding technique, there is a library in sklearn. From sklearn dot preprocessing, import label encoder. So this is a library in sklearn. Sklearn is a very famous library for doing all the machine learning task or feature engineering task. So we can import the libraries from there and do the task. So in which feature we are going to perform the label encoding? In gender feature, so mention all those features name. So gender, next is married, the other one is education. Dependent is also there because it is also a categorical, because we have seen in data.info that this feature is also an object can data type. Next is self-employed, because self-employed has two values, yes or no. Self-employed. The other one is property area. Let's see one more time. Check the df.info where we have written. Which one is object data type? Yeah, property area is object data type. Loan status is object data type. Yeah, in property area we have two values, ruler or urban. So we have to do encoding here also. So let's write property area loan status. So after self-employed, property, property area, loan status. So, so since we have imported label encoder, so we have to create one variable where we will call this function label encoder. So we have created le variable where we are calling this function label encoder. So now we have to apply this function on top of all this column. So we will use for loop. So for call in columns, df call in all the columns, we are fitting this fit.transform will apply this label encoding technique to all of the features for call in column. So call is basically the iteration it will do on top of all the features, and lead.fit transform will apply on top of all these features and make the conversion in the previous features and will make convert to a new feature. So let's run the cell. So now let's again check the data sets whether the features has been converted or not. So now you can see the gender. So of previously the first one it is male. So now it converted to 1. It means male is converted to 1 and female is converted to 0. See, in previously gender is male. In the first row married is no. So see, married is 0. It means no is converted to 0 and yes is converted to 1. So yeah, all the features has been converted. So now let's again check the data type. So there is d.types also, some one function is there from which also we can see the data types. So now we can see that all the features data type is converted to numerical data type. So let's start with creating independent and dependent features. So we did the feature engineering, data cleaning, and the data analysis. So let's start with creating independent and dependent features. So independent features are all those features which are directly dependent on the see see these features: gender, married, dependence, education, self-employed. These are all known as independent features, and our target feature is the loan status. So loan status is our target feature. So this will be our dependent feature. So all the features here is dependent on this loan status. So whether the loan will be approved or not. So we will divide this independent and dependent features for creating the machine learning model. So let's start with creating independent and not create, split independent and dependent features. So we will store independent features in X variable. So we will store the independent features in X variable. So in independent features, we have to just drop this one, loan status feature. Since all the features are independent except of loan status, so we will drop this one. So type df dot drop. So df dot drop columns equal to which column we are dropping? We are dropping loan status. So mention the loan status and axis equal to 1. Since it is column, so axis equal to 1. So after and y equal to yeah, the loan status. So this will be our independent and dependent features. Run the cell. So now this will be the two data set. Now it's been created. X. So in X data set, the target feature, that is loan status, is not present, will not be present. So yeah, and in Y data set, only the loan status feature is present. So yeah, we have splitted the data set into independent and dependent. For now our task is to create a machine learning model. So for creating a machine learning model, we have to import the ML models libraries from which we can train on top of our data set. So let's import all the necessary libraries from sklearn from sklearn dot model selection. First of all, we have to split our data set into training and testing. So from sklearn dot model selection, import, train, test, split, and cross-val score we can also import. Cross-val score, from which we can check the score of our model. So it is a cross validation. So it will do the I will explain you the cross validation score when we will check the score of our ML model after creating it. So yeah, so as sklearn is a famous library of whenever we have to build any kind of ML models, we can import the ML models or the encoders or train test split from there, and we can perform that task. So from sklearn.metrics, we can import accuracy score. So accuracy score is a score which checks that how much our model has accurately predicted the correct one and the wrong one. So it used to calculate those values. And a confusion matrix. Next, from sklearn dot linear model, we will import logistic regression. Import logistic regression. So this is the first simple classification machine learning model. So logistic regression is a simple classification machine learning model. So we will start with this, and after that we will train decision tree. So decision tree is also one. From sklearn.tree, import decision tree classifier. So decision tree can do both classification as well as regression task. But here our problem statement is classification. That's why we are importing decision tree classifier. So it is an ensemble machine learning model. We will train this model too. Next, after that, we will import random forest from sklearn dot ensemble, import random forest classifier. So random forest classifier is a kind of a model where multiple decision tree models have been trained out, and the averages of all those models have been calculated. So it is like those. For understanding all these models, you have to first, understand the theory behind that. So then only you can able to, get an idea more about the practical implementation. So, if you want that, okay, I have to upload, to clearly explain the theory concept behind this models, then ping me in a comment. And now let's just see the practical implementations of all these models. We will also import from sklearn.neighbors, import k neighbors classifier. So this is also a machine learning model. So all these machine learning models are, the supervised ML models. So we will import those, and let's run the cell. Okay, there is some error in the spelling. Let's run the cell. So it's not matrix, it's matrix. Let's again run the cell. So yeah, all the models have been imported now. Now we have to just do the first step is the train test split. It means that we will split our data set into training and testing. We have already splitted our data set into dependent and independent. Now we will split it into training and testing. So for so first of all, we will split our, the independent features into training and testing one. So we will create two variables, xtrain and xtest. In xtrain, the training independent features will be there. In xtest, the testing independent features will be present. Next, we will split our dependent features also in training and testing. So ytrain and ytest. We will name these two features as ytrain and ytest. Next, we will uh, call the train test split function that we have imported from sklearn library, and in that function we will give our dependent and independent features the testing size, like in what ratio we need to split our data set. So generally we used to fit 20%, 25%, or 30%. So I am giving out 25%. So what it does, it will split the data the data set that we are, giving out the independent and dependent features. So it will divide the X features into training and testing. Like the testing will be 25% and the remaining data will be in X stream. Same here in Y test, 25% of data will be there and remaining will be in Y train. Next, random state equal to 42. So this is also one of the variable. You can give any number to this. It will handle the shuffling of the values. So let's run the cell and do the train test split. Till then, we can write the code for logistic regression. So the first model that we are going to, train is the first one, the logistic regression model. So we can write the code for that one. So this is our model one. So in model one, let's call the logistic regression model by writing logistic regression. So we have called this model logistic regression that we have imported here. Now we have to fit this model to our training and testing, training data. We never fit the model to testing data. We will predict it on our trained model. So let's fit this model on our training data, fit to xtrain, ytrain. So whenever we do the model training, we fit the data, we fit the model on training data set, and after fitting, we will predict. So let's create a variable ypred in which we will store our predicted values. So model one, so we have trained the model one on the second line. Now we will predict it in third line. In which data set we will predict? In testing data set. So let's give X test name here. And after prediction, we have to check the accuracy. That means the performance of the model. So let's we have imported the accuracy score from sklearn.metrics. So we will call this, and we will check the score based on y-test and y-pred. So this y-test is our original testing data set, and y-pred is the prediction that the model has been predicted from trained data set. So let's run the cell and let's see the accuracy. What accuracy it gives out. Run the cell. So we can see that the accuracy, the total accuracy is around 77%. So we can convert it into a percentage by just multiplying with 100. Rerun. Yeah. So it's just giving 77%. So the logistic regression model is giving 77% model. So yeah, let's understand what is accuracy. Accuracy is nothing true positive plus true negative by false true positive. The sum of true positive. So let's understand accuracy in a simple manner. So accuracy is basically the ratio of the correctly predicted values to the total values. So it is the definition of the accuracy. So you can just check out in Google Colab, and you can just check in Google. You will get out like confusion matrix. Just wait a minute. Images. So here you can see that this is the confusion matrix. This is true positive, this is false positive, this is false negative, this is true negative. So true positive means the predicted value is positive, and the actual value is also positive. The columns that you are seeing is the actual value, the positive, negative, and the row that you are seeing, it is the predicted value. Since let's for example, let's see that uh, the real value is 1 and 0, and the predicted value is also 1. So it will come under true positive, and the predicted value, if the real value is 1 but the predicted value is 0, then it will come under negative. If the real value is 0 but the model has predicted it as 1, so it will come under false positive. If the actual value is 0 but the predicted value is also 0, then it will come it under in true negative. So it is also known as false positive, is also known as type 1 error, that is the predicted value is positive but it is false. False negative known as type 2 error, that is the predicted value is negative but it is false. So what is the formula of accuracy? Accuracy is basically the sum of uh, true positive and true negative by true positive plus false positive plus false negative plus false true negative. Accuracy means the sum of the correctly predicted values. So what is the correctly predicted values? True positive and true negative. Since you can see the definition, the predicted value is positive and the actual value is also positive. Here, true negative. So there is one more. Yeah, the predicted value is negative and it's actually also negative. So this is the two actual values, predicted values. So the formula of accuracy is the ratio of the correctly predicted values to the total values. Okay. So I hope you got it. So if you want to, get a more knowledge about it, like what is the accuracy, what is precision, what is recall, just drop me in a comment. I will explain you in more detail. Okay. So in my uh, next video, let's now move to the second model right now. But before that, we can also do the cross-val score. We have imported uh, accuracy score. With that, we have also imported cross-val score. So what cross-val score did, it actually the whatever the data set that we have, X train and Y train. So cross-val score split all this data set into number of folds, and fit that number of folds to the model, and then predict it, and then we can calculate the averages of all those values. So let's do that also. Score equal to, call this cross-val score function, and inside it write model 1. because we are doing the cross validation score on model 1, that is logistic regression. Mention the train dependent and independent features, and cross validation equal to, you can mention it 5, 3, 4, whatever you have to give. So what cross validation will do? So it will divide this our dependent and independent features into 5 folds. And by after dividing it into 5 folds, it will give out to model 1, and the model 1 will do the prediction on all these 5 folds. And after that, it will return the 5 values. Let's see the 5 values. What are those 5 values? Yeah, we can see the values are 0.81, 0.78, 0.780, 0.85, 0.81. In previously, it was returning only one value, because it was checking the accuracy score, or it was fitting the model on top of whole data set. But here it is first splitting the data set into 5 parts. Okay, and after that the model has been trained on that 5 parts, and after that it is returning the score. So we can use np.mean of all the score values and check the average score. So here you can see that it is returning almost 80%. So previously, when we are doing the model training on at one time on top of whole data set, it was returning around 77% accuracy. But when I did cross validation, that means when I splitted the data set into 5 parts, and after that I did training on whole parts, then it is returning 80% accuracy. So the accuracy has been screened out there. After that, we will do decision tree. The other model is decision tree classifier. So if you have to understand all these models in a deep detail, the theoretical concept or the mathematical concept behind that, then mention me in the comment. I will create one more video on top of it. So let's now run the other model, model 2. Call this decision tree classifier that we have imported. Next, same we have to fit this to our training data set X train, comma, Y train. And after fitting, we will again predict it, creating a new feature, Y pred. Here we will do the prediction. Model 2 dot predict on X text testing data set. And after that, we will check the accuracy of this model. For checking the accuracy, call the accuracy score function. And inside that function, first of all, give the prediction values that the model has predicted, and the after that the real values that originally it was, and then print accuracy score of decision tree model, and just multiplied accuracy with 100, convert it into percentage. Now run this cell. So now you can see that decision tree is giving 70% accuracy, which is less than logistic regression. We can also do the cross validation part here, score equal to cross val score. Inside that, we can mention X, Y. Uh, First of all, we have to mention the model. So this is the model 2, X, Y. Cross validation equal to 5, we can give it. Next, print cross validation score of decision tree. So it will return 5 values. So we have to, return the mean of that 5 values. So we will use np.mean to to calculate the mean of all those five values. So here you can see that there is not so much difference in doing the cross validation. I think the score has been deducted only. So it is not, every time it's not been helpful, but sometimes it is helpful. So yeah, we have seen that the cross validation score also. After that, let's see random classifier, what it did, the third model. Let's copy the code from above and make some changes in this code only. So this is our third model, model 3. This will be random forest classifier. This is random forest. In random forest, we don't need to do the cross validation because random forest has already splitted the data set into multiple parts, and then the decision tree model has been imported or fitted on top of all the data set, and then it was calculating the value. So in random forest classifier, we don't need to split the data set. We don't need to check the cross validation. So let's random forest classifier model 3, model 3 accuracy score of random forest. Run the cell. So yeah, the accuracy is around 80%. Next, the other model is K neighbor model. So this will be our fourth model. K neighbors classifier. This will be our model 4. Model 4 dot predict. K neighbor model. Run the cell. So here we have seen that this is giving 71% around. So we have seen that the logistic regression is giving a good accuracy. So let's understand the K neighbor model, how K neighbor model is working. So K neighbor model means the number of neighbors present around the values. So sorry, what I did, we have to mention here the number of neighbors that I missed here. Let's mention the number of neighbor, and neighbors equal to 3. So n neighbors equal to 3 means that we are initializing the neighbors values 3, and based on each 3 value it will check what is the neighbor, like what is the majority of the neighbor. If the majority of the neighbor is 1, then it will predict 1. If the majority of the neighbor value is 0, then the model will predict 0. So it works like this. So let's check the accuracy. So it is giving 72% around that. We can also do the cross validation here. Let's do the cross validation. Just copy the code from above, paste it here, convert it into model 4. And this is our K nearest neighbor. K nearest neighbor. Let's do cross validation in 3 parts. Run the cell. Let's see how much accuracy we are receiving. So the accuracy is not so much difference also. It is 72% only. So yeah, this is our 4 models. Logistic regression is the most simple classifier model, which is giving a very good accuracy of around 80%. Next is decision tree classifier. So decision tree used to split the data set into multiple, based on some conditions. And after that, it it do the modeling part, training part. Random forest classifier splits the data set into multiple parts uh, and then implement a decision tree model on top of each data set and then calculate the accuracy. K nearest neighbor just selects the highest number of values that is present around the neighbor's value, and based on that value, it will, like, if for example, uh, if uh, if the central value is one, and the nearest if the for example, let's see if there is any value, okay, and we have to predict that whether that data point is one or zero value, okay. So what KNN will do, it will check the nearest data values, and if the nearest data value has appearing more time one, then it will and then it will place that data value to one. If the more number of values uh, nearer the data value is zero, then it will place the data value to zero. So it's just check that what is the majority of the neighbors inside around the data value, and it will just replace those data value to the majority of the value present around its neighbor. So yeah, these are all the four, the models. But if you have to understand it in more depth, the it in more depth, and you have to understand the theory and the mathematical concept behind that, then ping me in comment. I will create one more extra video on top of it about the theoretical concept and the mathematical concept. So yeah, thank you so much. I hope you guys like it and just do all this practical implementations. So let's revise it once more. So first of all, I have installed all the necessary libraries for the data analysis and data cleaning. Read the data set, and then we have used head or tail to check the top five, and last top five features. Sorry, rows, and then we have did the data cleaning part. Like we filled the null values. We have seen the visualizations of the features. We have seen the correlation of the features, created a new feature, total income, applied logarithmic function, you know, to convert the skewed distributions to the normalizing distributions. And then after that, we have, dropped the unnecessary features that is not useful for us now. After that, we did label encoding, converting the categorical data to the numerical one, and then splitting the data set into independent and dependent features. Imported all the necessary libraries that is required for model training. Splitted the data set into training and testing part. And then we have trained all the four machine learning models, and we have seen the accuracy. The logistic regression is giving a good accuracy of 80%. We have calculated the accuracy score of k-nearest neighbor model. So now let's check the precision, recall, and FN score by looking the classification report. So there is a model in sklearn library. From we can check the report of all models that we have trained right now. So from sklearn.metrics, import classification report. So classification report is a kind of a library in which we can check out the precision, recall, accuracy of all the models. So uh, let's create a function to generate classification report of all models. Generate classification, and in classification report we have to provide inputs like model name, y true value, like y test or true value you can provide it, or y pred, the predicted value. And after that we have to just call out the and after that we have to just call out the classification report function, and inside which we will provide the y test value and y pred value. And after that we can print out like this: classification report for, here we will write the model name like model 1, model 2, model 3. So in that way it will give us the values report. In next line it will generate report. So now in the function we can provide each models. So let's first of all provide model 1 and then the model 1 test value. So I think the test value is same only. Yeah, you can see the test value y test is same for all the models. Let's give out this ypred model 1 so that we can give out this variable to all the models. So this is ypred model 1 logistic regression, and then after we have trained decision tree. So let's give out this name to model 2, ypred model 2. Make changes here also. Just rerun the cell so that everything is perfect or not. Yeah, we have to make changes here also. Model 1. Rerun the cell. Now check the accuracy. It's perfect. So this is model 2. So ypred model 2, we have make changes in the name. So here okay, there is some error in the spelling. This is also done. Next model is random forest. So here we have given name model 3. So let's write it model 3. There will be also model 3. Ypred model 3. Rerun the cell. Perfect. Model 3. Next model 4. Last one is model 4. So here just write ypred model 4, ypred model 4. Rerun the cell. Okay, so now it's done. Let's provide the model name. Y test will be same only for all the models, and y test, and in third variable ypred of model 1. Copy it and make changes for the other models. There is some error, like it will be outside the bracket. So just change model 1 to model 2, model 3, model 4. Now run the cell. So now we can see that classification report for logistic regression. So here we can see that for zero class it is giving precision 91%, for one class it is giving 75, for recall it is giving 39, and one for giving 98. So we can see that there is a very big difference between each class, because the values are very different. Like the difference between the values are too much. See, for here it is 39 and here it is 98. So there is some error. So there is some overfitting condition, or the imbalancing condition might happen in our training the models. That's the reason the report is coming like this. So let's see the classification report for decision tree. So decision tree have some better response. Next is random forest classifier. So it is also having a lot of difference in recall values and in F1 score value, which is not good. And next is k nearest neighbor. So here also a very big difference. So now just see, so now we can see by classification reports that there is some imbalancing error or underfitting errors. So just look at the target variable right now. So whether there is some imbalancing error or not. So let's see the loan status values dot value count. Dot value count is a function in which we can count the values, the number of values in each feature. So yeah, so total 422 values are present, which is being a 1, and 192 values present, which is being 0. So we can see that there is a very much difference because of that. So it gives an idea of you guys that whenever there is a such difference between the categories values, and when you train the model, then it will give a report, generate a report like this. So it is, so you can see that it is a kind of a basic model that we have trained right now. For training the model for balancing one, we have to do first of all balance, like we have to balance just values. So for balancing, we have one library. We can install it and do the balancing part. So there is a library called undersampling or oversampling. So by using that we can do the oversampling or undersampling. So we will do right now oversampling. Since 192 is too less, so here we will so oversampling will generate some values, and it will generate some values like this, so that it can, so that the difference between the number of values in one and number of values in zero, there will not so much of difference. So there is some library we have to install it. So let's install pip install u imbalanced learn. By using this, by installing this, we can do the oversampling. So now install from imblearn dot oversampling. So this is a library from where you can download the oversampling. Import random oversample. So it will generate random values in a minority class, and uh, and avoid the differences between the minority and majority classes. So there is some error sampler. It will be a sampler. Yeah. So it's done. Now let's write a code. So to balance the classes. So let's generate a variable oversample. Oh, sorry. So oversample. Next, random oversampler is a function inside which we can give the random state, the randomness it will generate. So let's give set it to, you can set any value. I'm setting it to 42. Next, x resampled Y resampled. So it is just like that we have created independent and dependent features previously. So now it is creating independent and dependent features in a resampling way. So previously it was imbalanced, now it is balanced one. So oversample. So now we are random oversample we have defined in a variable oversample. Now we will use this variable oversample to fit and transform, to fit and resample, to fit and resample to which values x and y. So x, previously x and y are the independent data sets. By using oversample, so this one oversample, we are doing the sampling, and it will give out x resample and y resample. And after that, we can convert it into data frame. Which data frames? Resampled one. So pd.concat pd.dataframe, f will be capital here, and we will provide the x resampled value. Column will be x dot columns. So previously the columns which are present, that will be only, so that's fine. Next, pd dot series. Series will be for dependent one. Y resampled, y resampled. Name will be loan status, because our target or dependent values are sorry, features are loan status. And this is column, so that's why we are giving x is equal to 1. Let's run it. So yeah, it's done. Now we can see our independent data set. Run it. So this is our independent data set. Now just check out the dependent one, that is y resampled. Run it. So this is our dependent one. Let's see the whether previously when we have calculated the loan status value counts, it is giving like this. Now again just calculate the value counts of this y resampled dot value counts. Just check out whether it is balanced or not. So now we can see that it is perfectly balanced. So now let's train the model on this balanced data set, and we can see the differences between the imbalanced model training and the balanced data set model training. So we can copy the code from above for logistic regression. Just copy the code from above. And we will make changes in the dataset name. So this is X train. So first of all, we have to do the train and test split on the balanced data one. So let's name the X resampled train dataset, X resampled test dataset, Y resampled train dataset, Y resampled test dataset. Okay. Using the function train test split. So inside train test split, we will give out the X resampled dataset, Y resampled. The test size we are giving is 0.25, 0.25. Random state we can choose 42. Let's run the cell. So yeah, it's done. Now we have to just make changes in place of X. So previously it was X train. So now since the data set is balanced, so we have named it to X resampled train. Just make changes in name only. Otherwise everything will be fine. Y resampled train. So X resampled test. Y resampled test. And yeah, YPRED model 1. YPRED model 1. Yeah, I think everything is fine. So let's run it now. Check the accuracy. Right here only. Multiplied it with 100. It is giving now 69%. And previously the accuracy of logistic regression model was, it was 77%. It means that our model was overfitted that time. So that's why, because since our target variable, the values which present in the target variable was very imbalanced one. So because of that, the model was overfitted and it was giving 77% accuracy. And the differences between the recall and F1 score was too much. So now it is giving 69. So let's train another model and let's create classification report for all the models and then we will compare. So now let's move to decision tree. Copy it, paste it here. So it was X resample. So it was X resampled train, Y resampled train, X resampled test, Y resampled test. Let's run the cell. So it was giving now 81% accuracy. Now after decision tree, the other model was random forest. Copy the code, paste it here, give the parameters values like above one. So yeah, it's done. Run the code. Yeah, so here will be resampled. It's giving 87% score. So after the random forest, there is another one named K nearest neighbor. Copy the code, paste it here, and make changes in the parameters values. Copy from here, paste it here. X resampled test, Y resampled test. We run the cell, it is giving 72%. Now we can again create a classification report just like above. Copy it. paste it here. So in place of y test, we will give y resampled test, make changes for everyone, each one. Apart from that, everything is clear. Now rerun the cell. Now we can see the classification report for logistic regression is giving 72%. So now we can see that there is not so much difference. Previously, there was too much difference between the precision, recall, and F1 score value, but now it is less right now. We can see the classification report for decision tree is really good. The values are not so much, difference from each other. The classification report for random forest is also good. So the best answer is providing by the classification report for random forest classifier. It is giving 90% precision, 87% accuracy. So k-nearest neighbors values are also aligning to each other. There is not so much big difference. So yeah, this was all the report that we have created. Previously, we have built a model. So previously we have built a basic model in a data set by just cleaning, done the label and coding. All tasks we have performed, data cleaning, data analysis. We have checked the outliers values, and based on that, we filled the null values. Whichever feature have more outliers, we have chosen the median value to fill the null values. And apart from that, we have used mean values. And for categorical, we have used mode values to fill those null values. We did data visualization. So previously, we can see that there is a lot of difference between this male, female, you know, no or yes. So in each category, there was the values are very imbalanced one. But now, that's the reason that the model that we have trained was not giving a good classification report. But after doing the after doing the resampling, we have balanced our data set, and now we can see that it creates a good classification report. So yeah, this is all for this video. If you want a more detailed information about each model, the theory and the mathematics behind it, write in a comment. If you suggest something, just write down in a comment. And if you have any doubt, you can write it in a comment. And next time we will come to a next new exciting project. So I hope you guys like it. Thank you so much.